Hi friends, in this video we are going to discuss about starters. Tell me, what is the importance of the starters or what is the purpose of starters? Generally, to start the machine is 100% wrong answer. Starters are used to limit high starting currents. This is the purpose of starters. Even though without starters also we can start the motors, but we have to take around 10 windings. If you start the motor without winding, without a starter, then the winding will bounce out. So again we have to rewound the motor and again start without starter. Again the motor will bounce out, again rewound, like that. Okay, so used to limit high starting currents, we are using starters. In generally, in DC machine, the current I is equals to V minus EB by RA, we know that. And here, by increasing the armature resistance, we can control the current like this. That's why we have to add extra resistance in series to the armature. Likewise, we can control the current in our DC machine. This is the process in DC machine to start the motors. Let's see, generally in our machine we have three types of starters. One is the 2-point starter, and next one is the 3-point starter, and last one is the 4-point starter. Like that we have three types of starters. In generally, these 2-point starters are used for DC series motors only, not for shunt and compound motors. This is used for DC series motors because this is the one point is the line, this is either point, if it is called as field or it is called as armature, either field or armature. This is the 2-point starter. And 3-point starters are used for, tell me, generally 3-point starters are used for 3-point machines like this. For example, line, armature and the field. Of course, for example, see, for example, like this. Here also we have a line, and actually this is armature, this is field. If you take a long shunt, this is field. So we have 3 points. That's why 3-point starters are used for shunt and compound machines. 4-point starters also used for shunt and compound machines. These both are used for shunt and compound machines. Are you okay? So actually here we have already 3-point starter for shunt and compound. Then why we are preferring the 4-point starter again? Nothing but in 3-point starter some disadvantages are there. That's why the 4-point starter also is there to overcome those disadvantages. So what are the disadvantages of the 3-point starter and what are the advantages of the 4-point starter? Let's see here. Generally, in 3-point starter, the field winding is in series with the no load coil, no load release coil it is called. What's that? Here field winding is in series with the no load release coil, but here field winding is separated and low load release coil is separated. Both are separated. I will show here. In 3-point starter, for example, if you are using flux control method, when we are using flux control method, the no load release coil activated and goes to deactivated and goes that this is deactivated and the speed automatically gets 0. The flux control method not possible by using this starter. If you are using 3-point starter, if you want to control the flux, nothing but we have to control the current, armature current, not that is field current. So during the field current, the no load release coil deactivated. When this is deactivated, the spindle goes to 0 and the speed goes to 0. So the flux control method is not possible. Here, armature resistance control method, no problem. This is possible. But the flux control method is not possible here. Nothing but above rated speeds are not possible with 3-point starters. Only below rated speeds are possible. This is the 3-point starter. What about 4-point starter? In this 4-point starter, this field winding is separated with no load release coil. Hence, the flux control method as well as armature resistance control method, both are possible, no problem with this. That's why the 4-point starter is used for especially flux control method, especially above rated speed control process. Because armature resistance control method is also there in 3-point. So this is designed especially for above rated speed control. This is simply the 4-point starter and 3-point starter differences. Are you clear? Now let's go for diagram of and operation of 3-point starter. I will show here. Let's see once how it will work the 3-point starter, how it will work that the 4-point starter. Let's see here. For example, I am taking a DC motor. DC motor is like this. For example, this is my voltage, line voltage, and this is my field winding. Or for easy analysis, I am taking here the DC voltage, here the field winding, and here I have a armature winding is like this. I want to connect a starter for this motor. For that, see here, I am taking one coil here. Let's see. This is called overload release coil. Actually, the overload release coil is like this. Like this. Here we have to connect to this one. This is connected to this one. Let's see here. From here, like this. And from this, it is connected to a spring. It is connected to a spring, actually is like this. This is a spindle. And this spindle is connected to a one arc is like this to move the spindle smoothly, and here we have a extra resistance like this. We have a extra resistance. See here, actually here the supply is there, nothing but this is the line. This is connected to a one coil which is called overload release coil, and from that to the spring, and from that to the spindle. One spindle is there, and this spindle have a soft iron piece. This is a soft iron piece which is attached to the spindle, and we are taking like this, and this extra resistance connected in series to the our armature. Of course, here to place this soft iron piece, here we have a one coil. This coil is called no load release coil or hold on coil. It will hold this soft iron piece. Of course, here also we should have a, what is that? Current supply. For that, we are taking the current supply from here. Let's see, from here, like this, like this, like this. And this is connected to a field winding. I said you already, in 3-point starter, the field winding is in series to the holding coil. This is the one very disadvantage of the 3-point starter actually. But let's see what is the operation and construction of our 3-point starter. And let's see here, actually from here we have a another like this, like this. Let's see. This is the our 3-point starter. This is the arc, just to smooth moving of our spindle. This is the extra resistance which is connected in series to the armature. This is the 1-point line, and this is the next point of field, and the another last point is armature. This is what our 3-point starter of DC motor. Are you getting or not? Let's see. Sir, what happened, sir? Just we have to give the DC supply here. This DC supply, when we are giving DC supply, then the current flows through the overload release coil. Of course, it produces some magnetic field. When the current flows through this one, it produces some magnetic field. Of course, this magnetic field and these soft iron pieces are somewhat separated by air gap. Nothing but this soft iron piece is away from the magnetic field. Then after current flowing here to the spindle, from spindle to the directly to the field winding, no problem for that. In generally in shunt machine, the current is directly to the field winding, and here another armature winding. Here I am going to connect extra resistance. So in series to the armature, I connected the extra resistance to control this current. I have to control this current. Yes or no? Actually, this is my DC shunt machine. This is the field winding, and this is the armature winding, and this is the supply. When supply is given, we have to control the armature current. That's why we have to add extra resistance in series to armature, not to the field. So this is directly connected to the field, but the extra resistance connected in series to the armature. When current to the spindle, then current came to the field winding, of course, and the current to the armature through the extra resistance. This is simply the 3-point starter. Sir, what is the purpose of this holding coil and no load release coil? Let's see. I given the supply. Listen carefully here. I given the supply, and supply is came to here. Now we have to cut this extra resistance which is in series to the armature. Now here the stud 1, and here stud 2, here stud 3, and this is the last stud. So I am moving slowly. When the armature resistance is cutting like that, the current increases. Then after what happens, sir? Back EMF increases. Then after speed increases, because we know the back EMF speed is directly proportional to back EMF. Initially back EMF 0, speed 0. Then after, when is current flowing? Actually due to high resistance, low current will flow. It produces some back EMF. Then after we are cutting and increases back EMF, and speed also increases exactly. So I am moving this spindle up to here. Then when this current flows through this holding coil, it already created some magnetic field. It is already created some magnetic field through this field current. Hence, when the spindle is moving like this, and this soft iron piece attracted by this hold-on coil. Now the soft iron piece settled in the hold-on coil. That's why it is called hold-on coil. When it is settled here, then the current to the armature is rated value. The process is going on. For example, suddenly overload occurs on the motor. When the overload occurs on the motor, what happens, sir? It calls for high line current. When overload occurs, it calls for high current. When the current is increased, actually my rated current is 10 ampere. Due to overload, the motor calls for 25 amperes of current. If this 25 amperes of current come here, actually for example my field current 5 amperes, armature current 5 amperes. When this 25 amperes came here, 5 amperes field current and 25 amperes out of 25, 5 completed. Remaining 20 amperes for armature. Is it possible? When this 20 amperes flows through the armature winding says, I am sorry, sir. Yes or no? That's why at this condition, when an overload occurs on the motor, then the motor should goes to off safely. For that reason, we are placing here overload release coil. Let's see how it will work. Let's see. When the overcurrent is flowing through here, given from the supply, then due to overcurrent, what happens, sir? The flux also increases more. This is the overcurrent flux. When the flux is over, this soft iron piece attracted by this overload release coil, then this is attracted. Actually my spindle is here, yes or no? Because it is rotating. Suddenly overload occurs. When current increases, this spindle attracted. When this spindle attracted, what happens are here? Short circuits will take place. When it is short circuited, then tell me, is the current flows through I1 or is the current flows through I2? Generally, the current flows through I2 because open circuited here. But when overload occurs, when this is attracted by this coil, then this is short circuited. That's why the current flows through the I2 like this. The current flows through the I2 like this. So what happens, sir? When the overload occurs, when the magnetic coil attracts this coil, this soft iron piece, then the current through this coil is zero. When the current is zero, then what is the magnetic field in this coil? The magnetic field in this coil also zero. Is our soft iron piece attracted by this coil? No, sir. When the magnetic flux is zero, this is released. Actually, there is no attractive force. Sir, there is no attractive force. Of course, there is no repulsive force. Then why the spindle goes back? Because here we have a spring. Here we have a spring. When there is no attractive force, the spring pulls back the spindle. Then when this is came back, then motor goes off. This is the action of overload release coil. Right? So this is the function of 3-point starter which we are using for shunt and compound motors. Next one. Sir, what is the purpose of no load release coil? Yeah, this is also called holding coil. And next one. Why this is not possible for flux control method? Let's see. Let's discuss about that. Why this is not possible for flux control method. Flux control method not possible in 3-point starter. I said you why. Let's see here. So now again I find that is overloaded and overloaded current is that overload is reduced. Now my motor is operating at normal load condition and it delivering the normal current to the motor. As normal current is flowing, and now I am going to, now this is not actually 25, only 10 amperes. There is no overload. Now my spindle slowly moving here, slowly moving here. Yes, it is attracted because here the current zero. This is now open circuited only, so current flows through this one only. Then there is a creation of magnetic field, and the soft iron piece attracted by the magnetic field. Here my spindle motor is rotating. Now at this condition, actually this is my field winding. Now I want to increase the speed of my motor. How we can increase the speed? By flux control method. How we can get the flux control method? Very simple. By adding extra rheostats. When this extra rheostat added, Here, in this case, the resistance increases, field winding resistance increases. Ultimately, the current is decreases. My spindle is here. Here, the current decreases. When the current decreases, the magnetic flux density, flux decreases. Again, the here resistance increases. When the resistance increases again and again, then again and again, the flux reduces. Nothing but the attractive force reduces. When the attractive force reduces, the spring pulls back the spindle, then comes to zero. That's why don't add extra rheostat in series to the field winding, because it will affects the no load coil, no load release coil or hold on coil. This is the disadvantage of my 3-point starter. That's why we are going for 4-point starter to overcome this disadvantage. Sir, what is the 4-point starter? How it is? Let's see. I am going to draw a 4-point starter here. Let's see. A 4-point starter. Here, the only thing is that in 3-point starter, what happens are the no load release coil and field winding in series. This is only the problem. So what we have to do for 4-point starter? In 4-point starter, we have to make a separate connection for no load release coil. We have to make that separate connection for no load release coil. Nothing but here the no load release coil should not be here. Of course, it should be here, but the field winding should not connected to this no load release coil. This is connected to one dummy coil by using one rheostat or resistance. Now the no load release coil is there, but this is connected to one dummy coil. Here we should have a field winding. Sir, this field winding should be connected to, again this field winding should be connected to extra connection. Now this is my field. Here, line, dummy coil, field and armature. We have a 4 points. If you want to add extra resistance in series to field winding, there is no effect for hold on coil or no load release coil. It will not affect. Now, always the current flows through this one, and this is the hold on coil current. When this is the in general is zero, if overload occurs, then current flows through this one, then at that condition, this is zero. Here, you can add extra resistance in series to the field winding, no problem at all. This is simply the 4-point starter of my DC machine, which is we are using for shunt and compound motors. Are you okay? Shunt and compound motors for above rated speed control also. Some fellows telling that 3-point starter used for shunt, 4-point starter used for compound. That is 100% wrong answer. We can use 3-point starter even for compound also. But above rated speeds not possible. For above rated speeds, we have to use 4-point starter only. This is what the starters of DC machine. Are you clear? Is it okay or not? Right. Thank you.